Hey, ladies and gentlemen, we are at 9.2. It says 8.2. It's 9.2. This is really 9.2. 9. Ignore that. It's a 9.2. All right. There we go. Inverse relations and functions. A relation is a set of ordered pairs. So we've done relations before. We talked about domain and range. Domain is our x values, range is our y values. They have to be listed smallest to largest and no repeat numbers. So if we look at our relation we have here, oops, I don't need that parentheses. You use a brace and then 1, 3, and 5. And then our range is going to be our y, so it's going to be smallest to largest, so 2, 4, and 6. The inverse we're going to talk about today is the set of the ordered pairs found by reversing the x and y values. So we're going to look at the same relationship, but now we're going to change it into an inverse. So it's going to become 2, 1, 4, 3, and 6, 5. So that's our inverse. We swap the x and y. And we're going to use that later when we do inverse functions. So if we look here, it says the ordered pairs of this relation are the vertices of a right triangle. So find the inverse and then graph both of them. So let's actually graph this first one. We're going to go over 2, up 1, over, oops, that was only 1. We're going to be over 2, up 1. Then we're over 5, up 1. And then we're over 2, but we're down 4. 1, 2, 3, 4. So we've got that here. So there's my original relation. Now we're going to do our inverse. So we're going to swap the x and y. And now I want to go ahead and graph this. So now I'm over 1 and I'm up 2. I'm over 1 and I'm up 5. And then I'm to negative 4, so to the left, 1, 2, 3, 4, and then up 2. And so if I connect this, this is my inverse. Now, inverse relations and function, or inverse relations are symmetric on our inverse function or relation y equals x. So if we folded our graph on that green line, the blue and the purple triangles would lie on top of each other. So now we're going to talk about them as functions. So we have inverse function f of x is f to the negative 1x. We've done inverse relations before when we talk about like inverse tangent and tangent. We use that. And so if f of a equals b and f of and then inverse function of b is equal to a. So when we look at our functions, f of x is the same thing as y. So we're going to replace whatever, if it's f of x, g of x, b of x, whatever, we replace it with y. So now my function is in x and y. Then my second thing we do is we swap the x and y. That's exactly what we did on the ordered pairs in our relation on the first and second slide. So swap x and y, that's your second step. And then our third step is to solve for y. So we're going to solve by y, and I'm going to subtract 2 to both sides. So I get x minus 2 equals y. We can rewrite this now and say the inverse function of x is x minus 2. I'm okay. I will take both answers, but just be cautious because not everybody does. All right. So then it says evaluate f of 5 and f to the negative inverse function of 7. So we're going to plug 5 into our original function. So x equals 5. So what that means, oops, is that my y value would be 7. Now if we look at our inverse function and we plug 7 into our inverse function, we're going to do 7 minus 2, and we end up with 5. And so what this just shows us is that the x and the y's have swapped. So here x was 5 and we got y to be 7. Here x was 7 and we got y to be 5. So that we have that inverse. X and y have swapped. All right, so we're going to use that same, just like what we did in problem 1, we're going to do here for this problem. So we're going to replace f of x with y. So step 1. Step 2, I'm going to swap my x and my y values. And then step 3, I'm going to solve for y. So I need to times by 2 on both sides. And then our last step is going to be we're going to subtract over the 6. So y equals 2x minus 6. That's my inverse function. Again, I'm okay if you leave it there. If you do this, that's fine too. All right, so problem 3, find the inverse of our function 5x plus 10. So first thing, replace y for the f of x. Step 2, swap the x and y, and step 3, solve for y. So I want you to pause the video here and see if you can do that for me. So swap the x and y, and then solve for y. All right, so take a look at what you got. I'm comfortable if you leave it as y equals x minus 10 divided by 5, or if you simplify that. Now, if there was like a 5 in front of the x, I would expect you to simplify that because you can simplify both terms. Here, it's not as easy. You have 1/5 x or x divided by 5. Both of those are fine. All right, so it says determine whether these two functions are inverse functions. So I'm just going to take my f of x function and I'm going to solve it to see if it gives me g of x function. So replace with y, my f of x with y. Now I'm going to swap the x and the y. And I'm going to solve for y. So I'm going to add 6 first. Plus 6, not 2. Y is not quite by itself yet. I have to get rid of that 3/4. You can either divide both sides by 3/4 or times by 4/3. I would suggest timesing by 4/3 because you have to times the x by it. Oops, I'm struggling to write down the right numbers today. Oh my goodness. All right, distribute that in. We get 4/3 x. And then just grab your calculator and take 6 times 4/3. And you do end up with 8. So if that's our function, I'll just write f to the -1 of x equals 4/3 x plus 8. That is equivalent to my g function. So yes, these two end up being inverse functions then. All right. So let's go ahead and look at some real world problems now. So everything we did before was just a basic function and it had x's and y's, it could have a's and b's, whatever. But when we put it into a real world situation, we do it just so slightly different. Here, we don't have to swap the x and y. So it says find the inverse of the area formula. Here, this is area for a circle. Area equals pi times radius squared. So what we're going to do is solve for r. So the first thing I'm going to do is I'm just going to simplify that into a. Now I want to get r by itself. So I have pi times r squared. So I either have to get rid of the pi or the squared. And we want to get rid of pi first. So we're going to divide by pi because those are being multiplied. So area divided by pi is equal to the radius squared. We want to get radius by itself, so we need to take the square root on both sides. So the radius is equal to the area divided by, or the square root of the area divided by pi. So what does the inverse function tell you? So let's first just go back to what the area function tells us. This says if I have my radius, I can plug it in and out comes my area. This inverse function says, hey, if you know the area, plug it in here, and you're going to be able to find your radius. And so that's what we're going to do for this second part. We have to find the radius when the area is 314. So again, we're going to have to do a little rounding with this. So you can round to 1 decimal place if you get a decimal. Just because we have pi and we have square roots, we know we're going to have to round. So grab your calculator and put in the square root of 314 divided by pi. And we get the radius to be approximately 10. It ends up being like 9.997 or something like that. All right. Then let's go ahead and use our formula for converting Celsius to Fahrenheit. So when you look here, if you plug Celsius in for X, out comes the degrees in Fahrenheit. So we are going to solve for the inverse. Again, I'm just going to simplify it into F, but I'm going to solve for my X. So I'm going to minus 32. So F minus 32 equals 9 over 5x. X is standing for Celsius. So we're going to divide by 9/5, or like we did before, we're going to times by 5/9. Now X equals, and this one I'm actually going to leave not distributed because it doesn't give me like a great nice number or a nice whole number. So I can leave it like this. If you distribute it, I think the fraction's like 106 over 32, something like that. So we can leave it just like this. That is fine. So what can the inverse function be used for? So our original function says I'm going from Celsius to Fahrenheit. So I'm plugging Celsius in for X, and my output F is Fahrenheit. And the inverse is going to go for the inverse. I'm going to convert Fahrenheit. I'm going to plug that in for F, and out comes Celsius. So to convert Fahrenheit to Celsius. All right. And there's where we're ending, ladies and gentlemen. Let me know if you have any questions. Have a great day.